So since we just learned about the formula for the sum of the roots for the quadratic, which is like if you have quadratic x squared plus bx plus c, we just learned that if the roots are alpha and beta, and the alpha plus beta values negative b over a, and product of the root is c over a. So alpha times beta is c over a. So when I look at this problem, since it has been given that alpha and beta are the roots of this equation, which is 2x squared minus 3x negative 2, value of a is 2, value of b is negative 3, and value of c is negative 2. Now, the value of the sum of the roots here, alpha plus beta, is going to be negative b over a. So negative b over a, which is negative of negative 3 over 2, which is 3 over 2 is nothing but the sum of the roots. So if you add the roots of this polynomial, you'll get the sum of the roots as 3 over 2. Product of the root will be c over a, which is going to be negative 2 over 2, which is negative 1. Since c is negative 2 and a is 2, it will be negative 1. Now the next part is you have to find out the value of alpha squared plus beta squared. Now for this, we already have these values. So alpha plus beta, the whole squared, when I use it, it is alpha squared plus beta squared plus 2 alpha beta. So since we already have this value, so alpha plus beta is 3 over 2, the whole squared, equals to alpha square plus beta square plus 2 times alpha into beta, which is going to be negative 1. So now if you bring it here, so it's 9 over 4. This is negative 2. If I bring it to the other side, it becomes positive 2, equals to alpha squared plus beta squared. So 4 twos are 8. 8 plus 9 is 17 over 4. So that's 17 over 4 is the value of alpha squared plus beta squared. Now, as far as alpha squared minus beta squared is concerned, what I would like to do is, would like to put it in a little broader context, that we'll put first it as alpha minus beta, uh, alpha plus beta. That's one way to do it. Or if you want to use the further second formula and all, you can always have an alternative to this. Since we already have this value, we just have to find this part, which is nothing but we will do by the quadratic normal identity. Alpha minus beta, the whole squared, is alpha squared plus beta squared minus 2 alpha beta. Since we already got alpha squared plus beta squared, which is 17 over 4 here, minus 2 times alpha into beta, which is alpha times beta, if you see, is nothing but negative 1. So that is negative 1 here. So 17 over 4, again plus 2. So this is 17 over 4 plus 2, which is going to be 25 over 4. So this is, if I alpha minus beta will become, so alpha minus beta will become root plus or minus 5 over 2. So that's your value of this. So once you put plus 5 over 2 times 3 over 2, and once you put minus 5 over 2 times 3 over 2 to get to this exact value. So that's how you do this part. Now coming to alpha cube plus beta cube, you will be using this identity, alpha cube plus beta cube, which links up with this one, is alpha cube plus beta cube plus 3 alpha squared, 3 alpha beta, and alpha plus beta. So since we already have this value, which is 3 over 2, the whole cube, equals to alpha cube plus beta cube plus 3 alpha beta, which is nothing but negative 1, and times alpha plus beta, which is 3 over 2. So when I simplify this, it'll be 27 over 8, and this is negative 9 over 2. So this side, it comes and become positive 9 over 2. So equals to alpha cube plus beta cube. And then you take LCM of this. That's the value of this expression. And coming to the final part, which is this part, will be taking the LCM of this. Will be alpha plus 2 plus beta plus 2 over product of these two. So I'm just doing is like the normal LCM stuff. So alpha plus 2, if I open this up with beta plus 2, will be alpha beta plus 2 alpha plus 2 beta plus 4. Alpha plus beta we already know is 3 over 2. So 3 over 2 plus 4 because 2 plus 2 is 4, and upon alpha times beta is -1 plus 2 times 3 over 2 if I take 2 common from here, and plus 4. So this becomes 11 over 2 plus, this is going to be 2 and 2 get cancelled. So 4 plus 7, 4 plus 3 is 7, 7 minus 1 is 6. And so this, if I divide 6 here in the denominator, it'd be uh, 11 upon basically 12. And the last part is 1 over alpha squared plus 1 over beta squared, which will be, if you take LCM of this, it'll be alpha squared plus beta squared over alpha squared beta squared. So alpha squared plus beta squared we already got here, which is 17 over 4. And alpha squared into beta squared will become 1. That is 17 over 4 is the answer for this part. So that's how you use the basic identities, basic sum of the roots and product of the roots to facilitate such particular questions.